Hi students, hello. I hope you are doing well. So, till now we have learned the concepts, right? The concepts related to your gas laws, right? Right from the starting of your basic concepts of your gas laws, basic terms in your gas laws, till your critical temperatures and other associated constants. Now, it's the time to apply these concepts by solving some numericals, right? So that's why I have selected some previous year IIT JEE and BITSAT questions, right? So now let's see how to solve a question from gaseous state. So why to waste time for this interesting topic? Let's start with our part. Previous IIT JEE questions, previous year's IIT JEE questions. So the first question. So the first question on the screen says that the behavior of a real gas is usually depicted by plotting compressibility factor Z versus P. Yes, right? We have seen Z versus P plots at high constant temperature, at a constant temperature. Yes, we are discussing about constant temperature. The plots are at constant temperature, Z versus P graphs. So at high temperatures and high pressures, Z value is more than 1. Yes, we have seen at higher pressures, your Z value is more than 1. So this fact can be explained by a van der Waals equation when. So we have to explain that using your van der Waals equation, right? So in any question, similar questions, you have to first understand the concept, get back to the basics. So basic says that your van der Waals equation gives you an idea about what is exactly happening for your ideal behavior, right? It is an equation for your ideal gases. So nRT. Now we know that at higher pressures what is happening? At higher pressures your Z value is greater than 1. It's greater than 1. Right? We have seen, for example, consider one gas like this. So at higher pressure what is happening? The pressure is increasing and Z value is increasing, right? So we have to use van der Waals equation obviously to explain what is happening, and here you can see the options are based on your constants. The options depend on the constants, right? So now what is happening at higher pressures? Your P is increasing, right? If P is increasing, what? P is very high. So if P is very high, what is happening? P plus something will be equal to P, right? Because if any value which is very high, and here A n square, A is nothing but, A is giving you an idea about pressure also, but this value of pressure is Y, then I can write P plus A n square by V square as P itself, right? Because here this value is very high at higher pressures, right? At higher pressures, and Z is usually more than 1. So Z is usually more than 1, right? Now V minus NB, obviously you can't neglect NB because volume is not higher. You can neglect NB at higher volumes, but here it is not higher volume, it is higher pressures. So NB still exists, it will be equal to nRT. So PV is equal to PNB, PV minus PNB will be equal to nRT. So it's plus. So what is happening, guys? Here my PV is depending only on what? It is depending on B itself. It is not depending on A, right? So what can I say? I can say now that it is explained by van der Waals equation when, and what can also you can say? You can also say that what is PV by RT? PV by RT is nothing but PNB by RT. Alright, I will write PV by nRT. So PV by nRT, nothing but PNB by nRT. I am taking nRT term to the left hand side. So it will be P NB by nRT plus 1. So here also you can say that your Z value is depending on what? It is greater than 1 and it is also depending on only the constant B. Right. So what will be the answer now? This fact can be explained by van der Waals equation when the constant A is negligible, not B. So A is the correct answer. So here it's a simple question related to your van der Waals equation. How exactly you are relating your van der Waals equation to your understanding of your compressibility factor and its understanding about your higher pressures. What is happening at higher pressures? So only B will be, the constant B is coming to the picture, is negligible. Next question. So read the question, students. So a cylindrical balloon of 21 centimeter diameter is to be filled up with hydrogen at NTP. What is NTP? NTP is again similar to STP. So from a cylinder containing the gas at 20 atm at 27 degrees centigrade. The cylinder can also hold 2.82 liter of water at NTP. So what we have to calculate? We have to calculate the number of balloons that can be filled. We have to calculate the number of balloons that can be filled up. So first, to solve this question, you have to understand one thing. What is my volume of a balloon? Because the question is what? The question is related to the calculate the number of balloons. So first you have to know what is the volume of the balloon. So the radius is given and it is also given that it is a cylinder. Right, it is also given it is a cylinder. Right, so what is the volume of a cylinder? What is the volume of a cylinder? What is the volume of a cylinder, guys? This is a cylinder of radius R and length L. So obviously right here you need to understand the length. You need to understand the length, but anything is given related to the length? Length, nothing is given, right? It is given it's a cylindrical balloon or 21 centimeters diameter, but no information is given about the length. So in these cases what you have to do is, you have to now consider the volume. You have to consider the volume to be a sphere, and volume of a sphere will be 4 by 3 pi r cube. Volume of the sphere now will be 4 by 3 pi r cube. Now since R is given, R value is 21 centimeters, volume can be 4 by 3 into pi 3.14 into r cube. So volume of the balloon is calculated, and volume of the balloon will be, if you calculate this, you will be getting in terms of centimeter cube, and you can convert into liter because 1 meter cube is equal to 1000 liter. So you can convert centimeter, 1 centimeter is nothing but 10 power minus 2 meter. So you can finally convert into liters, right? So convert centimeter cube into liters. How? First convert centimeter into meter and meter into liters, meter cube into liters. So the volume of a balloon turns out to be 4.851 liter. Now this question gives you some interesting ideas. What is the second line? In the second line it is given that the cylinder can hold 2.82 liters of water at NTP. That means at NTP, what will be the total volume? The total volume is not only because of 4.851 into N. What is N? N is nothing but the volume of N number of, the volume of the N number of balloons, plus also your 2.82 liters. Why? Because what is the volume of water? It is given as 2.82, right? So H2 plus half O2 gives H2O. So 1 mole of hydrogen gives 1 mole of water. That means equal volume, 1 volume of hydrogen gives 1 volume of H2O. That means 1 liter of hydrogen gives 1 liter of H2O. That means 2.82 liters of water is given by 2.82 liters of hydrogen. That means you already have 2.82 liters of hydrogen, and also this 4.851 into 9 is nothing but it is the volume of the gas present in your cylindrical balloons. So at NTP this is your volume. Now at 1 atm pressure your volume is what? This is at NTP, right? This one at pressure is 1 atm, volume is 4.851 N plus 2.82 liters. And what is pressure? Sorry, what is temperature? What is NTP? NTP is nothing but at your 25 degrees centigrade. So it will be 25 degrees plus 273, nothing but 298. Now let's get back to the first line of the question. So it says that there is at 20 atm, temperature is 27 plus 273, which is nothing but 300 Kelvin. Your volume is just 4.851 N. Sorry, your volume is just what? Your volume is now 2.82 liters itself, right? Because the cylinder already can hold 2.82 liters. So your volume will be 2.82. Because at 20 atm, a cylindrical balloon of 20 is to be filled with hydrogen at NTP, right? So cylinder is already having water, and from the cylinder you have to fill hydrogen gas at NTP. And you are having the pressure is 20 atm and temperature is 27 degrees centigrade. So it will be what? Pressure is 20 atm, volume is 2.82 liter, and your temperature is 300. So what is the relationship? P1 V1 by T1 will be equal to P2 V2 by T2. That means pressure initially is 1 atm, temperature is 298, and volume is 4.851 N plus 2.82. This value will be equal to what? This value will be equal to P2, which is 20 into temperature, this is 300 into volume, which is 2.82. So here from this you can calculate the value of N. So N value turns out to be 10. So I can fill 10 balloons. 10 balloons can be filled up. So this is a basic question, but you have to understand the concept. How the volume of a balloons have to be related with the volume of the cylinder is your first task. Once you understand, remaining all the parameters are given, right? And you have to use the ideal gas equation PV is equal to nRT, or you can say P1 V1 by T1 will be equal to P2 V2 by T2. All the values are given and you have to calculate the value of N out of it. So next question. Pure oxygen diffuses through an aperture in 224 seconds, whereas mixture of oxygen and other gas containing 80% of oxygen diffuses from the same in 234 seconds. What is the molecular weight of the gas? So this question is related to what? This question is related to your concept about your diffusion or Graham's law of your diffusion. So what Graham's law of diffusion says that rate of any gas A by rate of any gas B will be inversely proportional to square root of their molecular weights. It's nothing but mB by Ma. So if it is pure oxygen, rate is nothing but distance travelled by time T1 and xv by T2. This will be equal to mB by Ma. Now let's analyze the question. What exactly you are getting from the question? From the question, you are getting that if XA is nothing but the distance traveled by oxygen, XB is nothing but the distance traveled by this mixture of oxygen with another gas, right? You are given their times. So let the distance traveled be equal, let the travel equal distance. That means the time is different. So what one is 1 by 224 into XB and XA gets cancelled since it is same, and T2 is nothing but 234. So 234 by 224 will be equal to what? So it will be MB, which is the molecular weight of the mixture, by MA. MA is the molecular weight of oxygen. It is 32. So from this you will get what? You will get the molecular weight of B. So it is nothing but 234 by 224 whole square into 32. So you will get MB. MB is nothing but the molecular weight of the mixture. So MB value turns out to be how much? MB value turns out to be 234 by 224. Its value will be nearly equal to 35, or it is approximately 34.92. Its value is 34.92. So now when I am saying my molecular weight of the mixture is 34.92, what is exactly molecular weight? Molecular weight is nothing but, it is already given, 80% is O2. That means 80 into 32 is the molecular weight of oxygen, plus M into 20. What is M? M is nothing but the molecular weight of the gas, which is unknown. So this by 100 will be equal to 34.92. 80% is oxygen, so 80 into 32. 20% is your other gas whose molecular weight to be calculated, divided by 100 gives you 34.92. And what is now M? M is nothing but 34.92 into 100. (80 into 32 plus 20 M). So M value is nothing but the molecular weight of the gas. So it is nothing but this minus this. The molecular weight of the gas is 46.6. So this is how your Gram's law of diffusion is also useful in calculating the molecular weight of unknown gas, right? So once you know the rate of the diffusion, you can calculate the molecular weight of the other gas which is present in the mixture with the known gas. So Gram's law is also useful in this concept to know the molecular weight of the gas which is getting diffused with the known gas. For example, here the known gas is oxygen. So this is also an interesting question. Next question. So here you are asked to calculate the compressibility factor for carbon dioxide if 1 mole of it occupies 0.4 liter at 300 Kelvin and 40 atm. Comment on the result. So what is the compressibility factor Z? Is nothing but it is equal to PV by nRT. So what is pressure? Pressure is 40 atm, volume is 0.4 and number of moles is 1 into RT. What is R? Once your pressure is in atm, your volume is in liter, you already know that R value should be taken as 0.0821. Into temperature, temperature is 300 Kelvin. So your your Z value comes out to be nearly 0.65. Right, the first part is over. The compressibility factor is calculated. So here Z value is less than 1. So now what can I comment on the result? So you know that when your Z value is less than 1, at your pressure are intermediate. At intermediate level pressures, your Z value is less than 1. So for example, here the gas is carbon dioxide, here the gas is carbon dioxide. So for carbon dioxide, Z value is 1 at intermediate pressures. So what does that mean? If Z value is less than 1, that means the gases can be more compressible. At lower pressure, at intermediate pressure or lower pressure, the gas molecules are far away from each other. So you know that any gas molecules which are far away from each other, they can be compressed. So here I can say that since my compressibility factor of CO2 is less than 1, my CO2 can be compressed further. So that is the important outcome, or that is the result which can be outdated or which can be understood from this answer of Z value less than 1. So yes, the result is, I can comment on the result, Z value is that what? CO2 has to be compressed. I mean CO2 can be compressed further. So this is a important question related to your compressibility factor and your understanding of your plots of Z, which is compressibility factor. Hi friends, so for any further doubts you can open askIITians.com and you can find the discussion board, and if you click on it, you will get Ask Experts on the right side of the screen, and you select the category accordingly and you can post your question here. We experts at askIITians will be reverting you back within 24 to 48 hours. So students, these are some interesting previous year IIT JEE and BITSAT questions, right? Now I think you got some confidence, some mileage to solve other numericals using these sample questions, right? So till now we have discussed all the concepts related to your states of matter or gaseous state, right? We have started with the basic measurable properties. What are the measurable properties? We have seen the importance of the units. Next, we have seen how these properties of pressure, volume and temperature vary with each other in gas laws, right? And also we have discussed about your Gram's law of diffusion, which gives you an idea about what is happening to the rate of diffusion of different gases. And later on, we have discussed about your kinetics, right? Kinetic molecular theory of the gases. And afterwards, we have discussed how your real gas is differentiating itself from an ideal gas. And later, we have discussed about what are the corrections to be made in your ideal gas, which leads to your van der Waals equation. At the last, we have discussed about your critical temperature and other critical parameters like critical pressure and critical volume. And in the last, we have seen some previous year IIT JEE and BITSAT questions. So these are all these concepts in your gaseous state. Hope you understood all the concepts and numericals in gaseous state. Stay tuned to your sessions at www.askIITians.com, and you will be finding some more interesting topics in other chapters in your chemistry, physics and maths, right? So hope you enjoyed my sessions of states of matter. So students, keep tuned, take care, goodbye.